Let's implement a queue using stacks. We're given all of these empty function definitions of what a queue is supposed to be, and we're supposed to use stacks in order to implement this. And it says we only use 2 stacks, so that should be a hint that you should be using 2 stacks if that's not obvious enough. And we can only use stack operations. It doesn't really matter. We can use like an empty array or a deck, but we just can't use the same functions that a queue uses, obviously. These are the companies that asked the question, and I'm just going to start coding. So in the init, obviously we'll have to initialize 2 empty stacks. So we'll just call this S1 equals deck and S2 equals deck. And before we continue, I'm going to show you how this will work. There's an extra thing here that says it has to be amortized O of 1 time complexity. And that's just a fancy word for we want it to be O of 1 sometimes, but it's okay if it's not O of 1 other times in order to make up for that. So now to explain how this works, I'm going to have 2 stacks here, stack 1 and stack 2. And first, when we're adding things to the queue, of course, we're going to fill up this stack, and that's good. But when we want to pop from the queue, we can't just pop from the stack because, I mean, that's the top. We want to get the front of the queue, but the front of the queue is all the way down here. So how do we do it? Well, we basically just pop everything out from stack 1 into stack 2. And what we're left with is the front element, technically, of the queue on top of S2 stack. So we can just pop that out immediately. And the thing about this is, like, if you want to add something to the queue afterwards, you can't just start using S2. You have to pop everything from S2 back into S1, and then you can, put in whatever you wanted to put. So the amortized thing comes into play because if we're using S1 and we just want to append things to our queue, then all we have to do is just add them to our stack. And that's going to be O of 1 because we're just adding it to the top. If we're using S2 instead, and we're just popping things from the queue, so popping things from the beginning, like I said before, when we're using S2, the top of the stack will be basically the beginning of the queue. So popping things will be O of 1. But as soon as we want to switch those operations, like do things back and forth, like pop and then push and then pop and then push, then we have to, spend O of n time popping everything back into the S1 or the S2 stack and then doing those operations. So let's code that up. I forgot to put self dot before these because it's an object, so you have to put self dot. So just keep in mind, just be aware of that. It's kind of annoying, but it's how it works. So starting off with push, since we're making S1 the pushing stack, we want to check if we're currently using S2, because if we are currently using S2, that's kind of like our popping stack. So we have to move everything from S2 back into S1. So I'm going to say while S2, while self.S2, self.S1.append, self.S2.pop. And this works because if S2 is not empty, then that means we're currently using S2, so we just get all the things in there. Otherwise, it's just not going to run this condition, and we're going to end up with an O of 1 time complexity for this, which is just going to be self.S1.append X. For pop, it's basically the same thing, but the other way around, while self.S1. So if we have anything in S1, that means we're using S1. So we do self.S2.append, self.S1.pop. And this one does have a return type, so we're supposed to return self.S2.pop. For peek, it's like basically the same thing as pop, so I'm just literally going to copy it from there. But instead of popping, we're just going to return the first element on the stack, self.s2 of -1. And for empty, this is pretty easy. We're going to return not self.s1 or self.s2. So in order for the queue to be empty, both of these stacks also have to be empty. So since this condition is returning true if the queue is not empty, if we put a not in front of that, it's going to return the opposite. So if the queue is empty, it's going to return true, otherwise false.